First thing I want you to note, it says how much. How much indicates the what? Variable, that's right. So we're looking for the variable. How much indicates an amount of an alloy that is 10% copper. Do we know what an alloy is?
Yes.
What is it? Different metals. So a whole bunch of different metals combined together. So 10% of it is copper. So how much that's 10% copper should be mixed with 150 ounces of an alloy that is 40% copper in order to get an alloy that is 15% copper. How many things are we combining together? 2 to get a total of the 15, total of the 1. So I'm going to do 2 things. I'm going to set it up, and I'm going to write 2 equal signs. I'm going to draw a bar with a plus next to it to get our total. And the other thing I'm going to do is come over here, 2 things added together, get our total. So now I'm set up to go. So now let's pick apart the information. Again, we said we're looking for how much. So each of these need to say amount. And then what are the different percentages of the different things that we're mixing together? So the first amount is 10%. And we're mixing it with a 40% in order to get a what percent? 15%. Very good. Okay, now we have to decide our variables. So again, go back up to the top. It says how much. And again, you told me that how represents x, the variable, correct. So we're going to let x equal the amount for the 10%. And then it says, oh, it gives us the amount for the 40%. What is the amount? 150. Very good. To make a nice total of what? X plus 150. I don't think any of you had trouble last night remembering to put parentheses around that because it's a quantity. So that's pretty good. All right, and now we're ready to just take those straight into our equation. So we have these 2 together, these 2 together, these 2 together. Okay, Mr. Stoughton, would you set up our equation for us, please?
10x plus 40 times 150 equals x plus 150.
Times?
15.
Good job. Okay, for much of an alloy is needed. Let's just say 550 ounces of an alloy are needed. And it talks about antifreeze. So how much antifreeze should be in water? Should. 0%. So water is always 0%. So how much water should be added to a solution that is 70% antifreeze, and our goal is to get 60% antifreeze? How many things are we mixing together? 2 to get a total of 1. So let's set up our 2 things. Let and set up over here. 2 things added together make a nice total. And again, I'm picking up these key words. How much? How much? So again, how much? What needs to be in each of our let statements? Amount. Good. Okay, so of the antifreeze solution, again, how much antifreeze should be in the water to start off with? 0%. How much is in this mixture? 70%. And our goal is to get what percent? 60. Okay, next, how much water? So that indicates our variable, x. And I go along, oh, I don't see an amount or anything listed for 70, so let me skip it for right now. And I go on, how much of our total do we want? 35. Remember we talked about one like this yesterday. If our total is 35, let's pretend that this guy is 30. How much is left over for right here? 5. How did you do that? Subtracted from 35. Very good. So we do 35 minus x. All right, we have our setup. We're ready to go put into the equation. Miss Bocci, would you put into the equation for us?
It's 0x, which is just 0.
Correct. But I still want you to show it tonight just to let me know you guys know it's there. Okay, keep going on.
And then it would be 70 times 35 minus x.
Go ahead. I'm going to put that into quantities.
Then it would be 60 times 35.
Awesome. So Miss Bocci is right. We really don't need this ox right there. So drop him off. I'm going to show that he cancels. Positive 7 goes into 35 how many times? 5. So x is 5. And check up here, we do want 5 gallons. That was originally $7 and then increased by 65% to sell to a thrift store. Find the markup and the sale price. So if our original price, so again we did price plus the increase. If it was a decrease, we would subtract that right there of the original price equals the new price. That's what we talked about yesterday. And in fact, I could even just be right here and say 1.65 of the price equals the new price. So what is the price, the original price of the lamp? $7. But we need to figure out the new price. Alright, so that comes out to $11.55 is the new price. Now, I think that answered the sales price. That's $11.55. Does that answer the markup? No. So could you actually, do it in 2 and do 6.65 times that first? Absolutely. But right now, let's just do 11.55 minus 7 is 11.55 minus 7 is 4.55. Very good. So just to answer it, the markup is $4.55 and the new price is $11.55. How many ounces, I'm picking up that word right there, how many ounces of the peanut M&Ms should be added to the mixture? So how many, again, indicates the variable, and it also how many, we want to put amount. Now Mr. Sharma, what are the 2 things that I'm putting into my mixture?
You're putting the peanut M&Ms, and the cereal.
Okay, and then I'll put O's right here. So I did clearly label it so I can bring my eye back to those a little bit later. Alright, now, how many of the peanut M&Ms, that's telling me that maybe I should give that one the variable. So I'm going to put X right there. And then now that I added in there, how many ounces? 100. Okay, so Mr. Reiber, what's my total amount for the mix?
X plus 100.
X plus 100, good. Now let's go through and add. How much per ounce for the peanut M&Ms? $2.20. So make sure the decimal's in there. Versus the cereal is worth $2.
Yeah, the M&Ms are $2.
Oh, did I mix some? I'm sorry. All right. Is that better? Okay. And then I want to sell my mix for what? $1.40. Good. So on this one, I put this in here because I need you guys to pay attention to your decimal places a lot. All right, now that we have that set up, Miss Billings, would you tell me us what our first equation is going to be, please? Mm-hmm. Keep going. Perfect. Alright guys, do you want to get rid of the decimals? Or do you want to work with those in there right now? Who wants to get rid of them? Who wants to work with them? Okay, so this class is going to continue on with that. Alright, so we have 2x plus 0.2 times 100. That moves it over one space. So this is now 20. Good. Distribute, distribute. Equals 1.4x plus, move it over one place. We're now working with 140. Good. Subtract over 1.4x. And we get 0.6x. Subtract over 20. And we get to 120. Divide by 0.6. Can we divide by a decimal? No. So we move it over 1. We move this guy over 1. Ooh, that goes in nicely. 6 goes into 12 how many times? 2 times. 200. Alright. So, to answer the question, how many ounces of the peanut M&Ms? 200 ounces of the peanut M&Ms should be added. Water is 0, pure is 100. Alright, should be mixed with 4 gallons of a 30% acid solution in order to get a 80% acid solution. Okay, so Ms. Bocci, how many things are we mixing together?
2.
So let's go ahead and set it up. Let our total, and set it up over here. 2 things is going to equal our total. Again, I pick out the key words. How much indicates our variable, as well as what do we write in the let statements? Amount. We're looking for amount. Okay, so the 2 things I'm mixing together. I'm mixing together pure and 30. And what's my goal? To get 80%. So going back up to the top, how much pure? Pure gets the variable. How much of the 30 do we have? 4 gallons. What's the total amount? X plus 4. Mr. Reiber, set up our equation for us, please. Oh, what should we write next to the pure before we do that? 100%. Very good. All right, now, Mr. Reiber, do our equation for us, please.
100x
Uh-huh.
plus 30 times 4
Uh-huh.
plus 80 times the quantity x plus 4.
Perfect. Okay, continuing through, we have 100x plus 120 is equal to 80x plus 320. Good. Subtract over 80x. Subtract over 120. Ooh, that came out nicely. 20x is equal to 200. Came out really nicely. Divide by 20. What can we do with one of those zeros? Cross. And 2 goes into 20 how many times? 10. Alright, what's the unit we need to add on to this? Gallons. Good. 10 gallons of pure acid should be mixed.